welcome back, ladies and gentlemen. We are moving on to solving linear systems algebraically. So we just took a look at graphing these systems, okay, and seeing how they could work out. And it's well and good. Everything's great with that. The only issue is that you must have a graphing calculator or some way to graph these things. So we're going to take a look at today how we can use them to just solve algebraically. So our first part here is given the following two equations, how could you solve for both of the missing variables? What stands out to you as something they both equal? Can we use this to our advantage? So 3x minus 12 equals y, 2x plus 17 equals y. Well, the good news is, although the 3x minus 12 and the 2x plus 17 are different, they both equal the common variable y. All right, so since they equal the same thing, okay, by transitive property, if a equals b, b equals c, then a equals c, you can say 3x minus 12 equals 2x plus 17. Okay, and now we can go ahead and solve this. Plus 12, subtract 2x, x equals 29. Okay, cool. Now, if we wanted to solve for y, we could take this and plug it back into either equation. I'm going to go over here because why not? So 2 times 29 plus 17 equals y. 2 times 29 plus 17, 75. Okay, so our final answer could be 29 comma 75. Good stuff. All right, so what we've just done there, okay, is we did something called the substitution method for solving linear systems. All right, we want to solve one equation for one variable. All right, so we want to get one variable by itself. Okay, substitute that variable equation into the other equation, solve for what variable for that variable, and plug it into the other variable, which is basically what we just did. All right, so here's basically what we're doing with substitution. Solve the following by substitution and check with the graphing calculator. X minus 2y equals 4, 2x minus 3y equals 1. Both these equations, I want to get either x or y by itself. Which one looks like it would be easier to get x or y by itself? Hopefully at a quick glance, we notice the first one, x is already has a 1 in front of it, which makes it the easiest way. So if I add 2y over, okay, I get x equals 2y plus 4. Cool. What we're then doing, all right, is you're going to be using this to substitute into my second equation. It says 2x minus 3y equals 1. Well, up here, I know that x equals this quantity. So looking at my second one, 2 times x minus 3y equals 1. I'm going to replace x with all of this junk. Okay, 2y plus 4. Cool, that's substitution method. We're taking this and we're substituting it in for x. All right, now I can solve this, distribute 4y plus 8 minus, that's a minus, not an equals. Okay, 4y minus 3y is y. Subtract 8, y equals negative 7. Cool. Well, now I got to plug it back in, and you go back to your two initial equations, and I could even use this if I really wanted to. I want to get x by itself. So here I already have x by itself for my first equation. So x equals 2 times y, which we now know is negative 7. So negative 14 plus 4, x equals negative 10. Cool. So my final equation is negative 10 comma negative 7. Good stuff. All right. When it says check with the graphing calculator, you may graph this if you'd like, but then I have to go back and get everything equal y equals. So here's my answer. Let's just plug this in. Negative 10, negative 2 times negative 7 is 14. Sorry, positive 14. Positive 14 minus 10, 4. Good stuff. 2 times negative 10 is negative 20. Negative 3 times negative 7 is positive 21. 21 minus 20 is 1. We're good. Okay, you just did a quick check. We're good to go. And by all means, use a calculator if need be. All right. So that was substitution. Now, there are some hindrances with substitution method, okay? You want to have either x or y by itself, pretty easy to get to. Next, we're going to take a look at what's called a linear combination method or the addition method. I will kind of preface this by saying this is most likely the one that you guys are going to get the best with. This is the one that has the most benefits. It always works. Okay, like substitution can get annoying sometimes. You get a lot of fractions. but linear combination, life is good. Multiply one of the equations by a constant on both sides. The leading coefficients are opposites of one another. Add the equations, solve for the variable left over, plug in, find the error coordinate. So what we're doing here is this. X minus 2y equals 4, 2x minus 3y equals 1. I basically want to get either the x or the y to cancel out. So you're allowed to multiply through these equations by a constant to do so. So I have a positive 2x down here. I would love to turn this one up here, this 1, into a negative 2. If I can do that, when I add them, they'll cancel out. Well, we're going to multiply the top equation by negative 2. There are multiple ways to do this, but this is probably the easiest way, all right? Negative 2x plus 4y equals negative 8. Now my bottom equation is going to stay the same. 2x minus 3y equals 1. But what happens is if I add these now, negative 2x plus 2x, see you later, cancels out. 4y minus 3y, get lucky and it's just plus 1, or just 1y. Negative 8 plus 1 is negative 7. Okay, cool. Well, you pick which one we'd like to plug this back in for. I'm going to just go with the bottom equation because why not? 2x minus 3, my y is negative 7. Okay, I'm just solving it now. 2x plus 21 equals 1. Subtract 21 over. Divide by 2. X equals negative 10. Okay, so my final answer is negative 10, comma, negative 7. Good stuff, all right? And again, if I really wanted to, negative 10, negative 2 times negative 7 is positive 14, okay? You get the idea, right? And if I'm not mistaken, I believe it's the same exact one as back here. So you can see we double checked it already. We got the answer, okay? All right, well, obviously, you know, hey, sometimes it works nice with this, and so on. Here's where it can get a little bit more difficult, all right? And here's where you get to be creative. I don't have an X or a Y by itself here, so I can't really use substitution too easily. I could possibly work something down here, but linear combination method is nice in the fact that take a look at your 5 and your 3. What's the least common multiple between both of them? Well, it's 15. Okay, cool. I'll get right back to that. 4 and 9, the least common multiple is 36. I'd rather work with 15. So what I mean by that is I'm going to multiply the top equation by 3. Everything I'm going to multiply by 3. This gives me 15x plus 12y equals negative 90. Now I'd love to turn this positive 3x into a negative 15 because then it will cancel out. So I'm going to multiply the bottom one by negative 5. Negative 15x plus 45y equals positive 90. Let me double check there. Cool. Okay. If I add these now, this is going to cancel out. 12y plus 45y is 57y. Negative 90 plus 90. Good luck, or good looks. 0. Divided by 57. Y is 0. Cool. Take your pick. You want to go to the top equation or bottom equation? I'm going to go top equation because reasons. I don't know. Plus 4. Plug a 0 in for y. Okay. Cancels out. Divide by 5. X equals negative 6. So negative 6 comma 0. Nice. Double check real quick. All right. 5 times negative 6, negative 30. Cancels that out. Boom. Negative 6 times 3 is negative 18. 0 cancels that out. Boom. We're in good shape. So linear combination might be a few extra steps, but it will always give you the right answer. So you now have 3 opportunities. You can graph it. You can do substitution. You can do linear combination. Just keep in mind that you might not always have a graphing calculator on you, right? But yeah, all right. There you go. You can put them out into your toolbox. It'll help you down the road. Keep it to go work. As always, good luck. We're all counting on you.